Dear students, welcome back to the online sessions on DCCN. So before we go into the network layer concepts, what I want to say is I just wanted to discuss once again the basics whatever we just had. We just have a quick recap of looking into the important points which are really necessary to understand the data link layer. Okay, so the network layer, sorry. So we have discussed about various standards which are really required. Standardization is really required so that it supports manufacturing of various types of devices in the network by different vendors. Therefore, standardization is going to be a very important aspect of it. And next we have discussed about standard organizations which approve the protocols and work done by various vendors. And we discussed about all these various standardizations, and we discussed about OSI model, which is very important, which is known as a layered network architecture, which is responsible for communication in the network. So whichever computer wanted to communicate their signal in the network, all the computers has to satisfy these 7 layers of the OSI model. So this is what generalized model, where every computer has to really satisfy this functionalities of these 7 layers if at all it want to communicate in the network. Then next we discussed about the independent layer. This slide is going to speak about the given functionalities. All these are going to be the total communication functionalities are simply divided into 7 layers. Every layer has to perform its own intended task. Apart from that, it has to give a service to the upper layer and the down layer. So like this, every layer has to really perform a specific task, right, which is independent to other layers. So other layers need not bother about the present layer. So that is what the advantage of this layered network architecture. So we can have simply a plug and play operations. Whichever layer you wanted to upgrade, you can simply upgrade only that layer without affecting the other layers. That is the advantage we are going to get. So every layer is going to provide addressing method so that the data which is coming into the layer has to be given to the subsequent layers. So therefore service access points has to be given to each and every layer. And next is it has to provide the functionalities of that layer, and it has to provide the protocol specifications of that particular layer. So this is what the layer independently we have discussed, and the entire operations, the operations in the data communications are performed by using the protocols. Therefore protocol is going to be a very important aspect, and we discussed about this protocol in the last session. And next we discussed about the various layers like physical layer, data link layer, okay, and a network layer. So we are here now, we are into the network layer now. In the network layer, the first point is what now? Transport of information. What do you mean by transport of information? We wanted to transmit the signal from source computer to the destination computer. So while transferring this information from source to destination computer, the network layer has to compulsorily perform some functionalities. So what are the various functionalities and network layer can able to perform? It can perform 5 functionalities. First one is, as we discussed, internet working, addressing, routing, fragmentation and packetizing. So these are the various functionalities the network layer has to compulsorily support. So once the network layer is going to support these functionalities, the other 2 points are going to be simply inevitable. What is the other 2 points? Higher layers do not need to know about the underlying technology. So that is what the basic necessity of going into a layered network architecture. Whenever a particular layer is going to implement some operations, some implementations, these implementations and operations need not be known to the other layers because they are totally specific to the network layer. That means all the other top layers such as transport layer, session layer, presentation layer, all these layers need not bother about what is underlying network technology. So that is what the basic benefit of this kind of layered network architecture. So this point is purely on the layered network architecture. The next important point is that we don't use network layer if we have a direct links. We don't use network layer if we have direct links. So that means direct link is very simple task to do. That means 2 computers are there, these 2 are connected by direct link, direct LAN connection. So therefore I need not go with the network layer especially. So I go to network layer only whenever I am going to have multiple links in the network. So this is what important point for us. Then next we have got the medium. Very importantly, we got two types of mediums, wide medium and wireless medium. In the wide medium we are going to have twisted pair, optical fiber, coaxial cables. In the wireless medium you are going to have air, water and vacuum, going to be the wireless medium of data transmissions. And coming to the link, we are going to have three different types of links. You are going to have a direct link, you are going to have the point to point link, you are going to have the multi-point link. So what do you mean by direct link? You never come across with the intermediate devices or nodes, that means or repeaters or relays. Straight away two computers are connected directly. Whereas coming to point, there are going to be a direct link, only two devices are going to share the link. Then multi-point is nothing but, this is the actual internet working network. So where multiple devices are going to share a single link. That is what the basic application of the internet under consideration. So whenever we transmit, we are going to have three modes of transmissions. As usual in the communication system, every communication system has to support simplex, right? So it is going to support three different modes of transmission: simplex, full duplex, half duplex, which we already dealt in the previous chapters. And the communication system is going to comprising of these blocks such as source computer called as workstation, destination computer called as server, let us suppose, and these two are connected by modems to the public switched telephone network. So this is what the basic architecture or basic. So we are discussing on this, that is the basic block diagram of a data communication system. So data communication system is simply been connected by using modems, and these two modems would be connected to a public switched telephone network. So the workstation and a server can be devices, can be mobile phones, can be any electronic gadgets. So like this communication is going to happen in the data communications as well. So after that, what are the various functionalities, tasks or procedures need to be implemented in the communication system? First one is transmission system utilization. We have to compulsorily have a transmission system, something like a transmitter, and we need to provide interfacing between various layers in the network, and signal generation should be a separate part. Synchronization of the data between source and the destination has to be there. So this synchronization we normally perform in the layer network architecture. So where we normally prefer or use synchronization in the layer network architecture, usually we do this at the session layer. Okay. So the next one is exchange management. Exchange management comes under once again control signals. So control signals can also be transmitted by using a separate protocol called ICMP protocols. Then error detection and correction can be done at the data link layer. Addressing and routing is done at the network layer. Then recovery, once again at the recovery can be done at the transport layer. Okay. Then security, we provide security at the presentation layer. Network management, that means whenever a network is not working properly, you have to compulsorily transmit some networking control signals to control the network. So for that we are going to use the network management protocols. So why we go for internet working? Why we go for networking? So here we go for networking to address the communication when the devices are too far apart. That means whenever we are going to have devices which are too far apart, to have a communication between them, we use the networking concept. Then large set of devices would need impractical number of connections. See here what happens is, when network is going to be huge network of networks, then you're going to have impractical number of connections. To deal with such high complex system connections, we use the networking concepts. So the only solution is networking protocol. So what is the simple model of a network we are going to look into now? A network is something like See, first of all, every system is going to have some information to transmit, and you're going to have a transmitter which is going to transmit the signals, and next you're going to have a transmission medium or transmission system. So which is comprising of maybe a wide communication, wireless communication. If you think it is of a wide communication, imagine a local area can be connected. It can be connected today to a wide area network connections, where all these circles are known as the switching nodes. They can be called as routers, they can be called as bridges, they can be called as repeaters. So like this, we normally going to use combination of various routers. So to the each and every router we'll be connecting many other computers. So like this, we can just have a wide picture of the simplified network model. That means a network is comprising of many other networks in the process of communications. Okay, that means if this is a source computer, I can take this as a destination computer, and a signal is going to get traversed by any one of the paths to the destination computer by following this particular basic block diagramic representation. That means this is going to be the source computer, which is going to have the source and the transmitter. It is going to transmit the signal in the transmission. That means what now? This entire system is going to be called as a transmission system. This is going to be known as a destination system, and this is going to be called as a source system. So like this, we can just think the overall structure of a networking model. So local area networks, we are not discussing on this. We have to discuss only purely about the networking part. So networking means what? We can have a network of a bus topology, we can have a network with a ring topology, we can have a network with a tree topology, we can have a network with a star kind of a topology. So star topology, in star topology you are going to have a centralized hub. Every computer is normally going to transmit its data to the central hub. From this central hub, that information will be traveled to the all other respective nodes. So like this, we normally going to have different types of topologies in the network. So very importantly, we use star topology in the real-time applications. So star topology is always going to be preferred in the data communications model. Say for example, using the bus LAN network, how the data is going to get transmitted. Say computer C want to send a data to computer A. So what this computer C will do? This C computer is going to send a data with address A. Now this data is transmitted using a bus topology. Therefore this data will be traveling to station B. When the computer B or station B is going to receive this data, it finds that it is not for this particular station. Then simply it won't accept the data to get received. So therefore this data is simply going to get passed through further nodes. So whenever a node whose address matches to its address, whenever a node whose address matches to the address of the data frame which is coming, and that particular computer is normally going to accept that particular data. So like this, we normally going to transmit data in the internet working. And like this, we are going to have ring topology connections, we can have like this. And coming to star topology also, we are going to have the same kind of connections. Okay. Then for wide area networks, we use especially, we have to communicate from one device to another device. How do we communicate? We employ circuit switching methods. These are known as various connection technologies. So we can connect computer 1 data to computer 2 data with the help of circuit switching technology, packet switching technology, frame relay technology, and asynchronous transfer mode technologies. These 4 are the 4 technologies using which we normally going to connect source computer to the destination computers. So as we discussed earlier long before about circuit switching. So in first unit we discussed about circuit switching. Once again I just recap with this. So circuit switching means what? It is known as dedicated communication path. Whenever you are going to have a fixed connection, dedicated connection, that type of connection is known as a circuit switched path. So now here this circuit switching path can be made as a virtual network. Whenever a computer A want to communicate to computer C, then a virtual network will be created. So after the network path got created, which is nothing but dedicated path until the communication is going on, that is simply can be called as a circuit type of a switching. So where we are going to use switches to communicate computer 1 data to computer 2 data. That's very simple. So the example is going to be simply a telephone network. That means 20 years back we used to have only the analog mobile phones, analog phones. The analog phones are going to get connected by the circuit switching type of a network, right? So here what is happening, whenever a user is going to make a call, a network is going to get established which is dedicated for these two users until the call is in progress. So that's how the telephone conversation is going to happen using the circuit switching type of the network. Then another type of switching technology which we use in networking is something like packet switching network type. So in packet switching network type, what we do is we simply convert the big data, whole data into smaller chunks of data known as packets. So as I am talking to you, it is known as packet switching. The networking layer or network layer is going to give the output as a packet. So we already discussed about these points. There are three important layers which we have. That is, first one is transport layer. The data coming out of transport layer is called as message. The data coming out of network layer is known as packet. The data coming out of data link layer is known as frame. So that means these terminologies are very important. So as we discussed earlier, therefore here in the packet switching, data sent out of sequence in terms of small chunks of data known as packets. So this packets term is very important. So in terms of packets we transmit the data. So packets are going to get passed from node 1 between node 1 to node 2 or between source to destination. That means it is used for computer to computer communications. The next one is frame relay. So frame relay is going to be one more technology used which connects the one packet to the another packet. Okay. So all these things we can discuss in the transport layer. So I can just skip this here now. The next protocols. Yeah, this is important for us. So what are the protocols we are going to use to enable the communications? So what do you mean by a protocol? Protocol is known as a set of rules which governs the communication between the two devices. So that means protocols are normally used for communications between entities in a system. So it means it provides set of rules which governs the operation of the communication between the two devices is called as protocol. So the protocol should speak the same language. This is important point. So the two computers whichever want to communicate, they have to speak the same language. Then what entities the protocol is going to use? The protocol is going to use user applications, email facilities and terminals. That means user applications means what? User applications will be manifold like FTP, SMTP, Telnet. So all these are something like user applications. And email facilities, nothing but SMTP and many other facilities, multimedia facilities we can have. And different types of terminals, peer-to-peer terminals and the client server terminals, we are going to have different type of terminals. And systems, what type of systems are normally used in the protocol architecture? We are going to use computers, we are going to use terminals, we are going to use the remote sensors and we are going to use the portable, one more has to be there, portable devices. Okay, these are the systems we are going to use. So the key elements of protocol is going to be, every protocol is going to have some syntax which is going to contain data formats and signal levels, and it is going to follow some semantics such as control information and error handling capabilities. And every protocol should specify the speed matching and sequencing. That means what is the speed of communication, communicating a packet also has to be specified. So characteristics of a protocol. What are the characteristics a protocol is going to have? Direct or indirect, monolithic or structured, symmetric, asymmetric characteristics, standards, non-standard type of the characteristics. So what do you mean by direct or indirect characteristics? So in the case of direct characteristics, systems share a point-to-point link. That means in the case of direct, there should be two computers connected point to point. There is no intermediate node here. So systems share a multi-point link. So in the case of multi-point link also it comes under a direct link. Data can pass without intervening active agent. That means there is no active agent, means there is no repeater in between, there is no amplifier in between. So straight away the data is normally going to get transmitted. Indirect transmission means what? Indirect characteristic. What is the next protocol characteristic? Is called indirect. So which is nothing but switched networks or internet works or internets. So indirect means what? We use switched networks. Just now we discussed circuit switching, packet switching. All these are going to come under the switched networks. Then symmetric and asymmetric. Symmetric means what? Communication is going to happen between peer nodes. Peer nodes means what? The nodes of same capacity are called peer nodes. That means students of a same class when they are communicating. What we call them as? We simply call them as peer-to-peer communication. When a student is communicating with a lecturer, it is not going to be a peer-to-peer type of a communication. That means when two systems of same capacity are communicating, that is called peer-to-peer communication. That is called PEER, peer-to-peer communications. So that comes under the symmetric kind of a communication. Then asymmetric means what? Client-server based communications. So client-server means what? Client and server both are going to run with different capacities, because server is going to be with very high capacity in comparison to the client. Therefore, that is going to be that comes under the asymmetric characteristic of the protocol. Then standard, non-standard. Non-standard protocols built for specific computers and tasks. Yeah. See here, standards means what? Everybody has to compulsorily fix to a particular set of programs, right? Those whoever don't want it to fix to that, they want to do something customized kind of implementations, then they have to go for the non-standard kind of a protocols for their own specific computers and tasks. That means it is going to be something like a non-standard type of the implementations. Okay. So use of standard protocols. Standard protocols means what? Say for example with standards, say for example these nodes are communicating with these nodes. When the link is going to be a single link, then it is going to follow the standard protocols. In standard protocols, all these nodes has to use the same protocol. That means single protocol has to be used by all these nodes because it is standard. That means everybody should satisfy themselves to the standard protocols, themselves to the standard predefined protocols. So that is why it's going to have only one protocol and 7 implementations. Whereas coming to here, these nodes are different. That means they are without standards. So any node can communicate to any other node. So in that process, you can have your customized number of protocols and customized protocol implementations. So this is what standard protocol, this is going to be a customized protocol. That means standard protocol is going to be a simple communication protocol, whereas customized called as non-standard is going to be a complex protocol structure. Something like the standard protocol is something like OSI model. So if you are going with OSI model, it is going to be fixed. Every layer, every computer has to follow all the 7 layer implementations. That is called a standard protocol architecture. Whereas coming to non-standard, every computer need not satisfy all the 7 layer implementations. So therefore, it is going to be totally customized implementations. That is what the benefit. The next one is monolithic and structural. Monolithic means what? Monolithic is normally suitable for communications. To perform communications, communicating in monolithic is going to be a complex task. Now we have monolithic device. What is the meaning of monolithic? All the various components of a system are normally going to sit in a single place, at a single place. That is going to be called as monolithic. Nowadays, the TVs that we are getting is going to be monolithic TVs. Means what? That is why Flatron TV is coming. Flatron means what? Flatron is going to have monolithic architecture. So all the components are going to sit on the same panel. That is what called monolithic. But it is going to be perform complex tasks. Monolithic means what? Different types of signals has to be implemented on a single chip. That is a very complex task. So therefore monolithic is going to be too complex for a single unit. So that is what the thing you are going to have. The next one is structured design. Next one is structured type of the architecture. In this, structured design breaks down the problem into smaller units. So structured design is going to be pretty easy because of the structured designing, that is C programming. C programming is nothing but a structured programming language. Why it has become structured programming language? Because you are simply breaking down the entire program into small modules. Therefore, we can call it as a modular programming language. So because of the structured design, what we can do is we can divide the given problem into small sub problems, small sub units, and we simply going to execute all the programs one after the other based on the sequence given by the programmer. So therefore, this is going to be this, and this structured design obviously comes under the layered structure. So once again, various functions of a protocol. What protocol has to do? Protocol has to perform encapsulation, segmentation, connection control, order delivery, flow control, error control, addressing, multiplexing, transmission services. Because all the layers are going to have a protocols. Every layer is going to speak about itself by using a protocol. Therefore, almost all layers functionalities will be provided in the protocols. Okay. So this is what we have basically on this. So we can just go through like encapsulation. Encapsulation means what? Something like, embeddedness. We are going to embed many things in a single box is called encapsulation. So addition of control information to data. This is data actually coming from application layer. To this data we are going to add some additional information. That means what? We are simply encapsulating the control information to the data. And we are making like a capsule, small capsule which contains something like a multivitamin tablet. So address information we are going to add to the data, and we are going to add error detection code, we are going to add the protocol controls. So these data we can simply going to perform, which is nothing but the encapsulation. Okay, that means your application data is divided into two, header and the actual data. So that means we can divide them into two parts, and we provide more amount of information to understand about the data at the packet itself. The next one is segmentation, is known as fragmentation. When the data is going to be huge, we implement segmentation. That means we simply chop the data into small segments, then we allow the data to transmit as small chunks of data. So the next is fragmentation. What are the advantages of fragmentation? Why we go for fragmentation? If you divide the huge amounts of data into small chunks of data, the error control is going to become very effective. The next is more equitable access to the network facilities. Because in the network, in the internet network, we normally going to use the networks with different capacities. So therefore, if you use a small data, anybody can handle small data. Therefore, the network utilization of network facilities is going to become pretty easy. And definitely, since data is very small, the delays are going to be small. Smaller buffers needed. Memory in the intermediate nodes is also going to be very small needed. So that is the advantage. Now what are the disadvantages? Of course, there are going to be overheads, because the given huge data, the given data is divided into small chunks of data. So therefore every data is normally going to have some overheads, which speaks about the data, where from it is coming, where it is going, what type of formats it is going to follow. All those things has to be added. What is the control information? So much data is added to that. Therefore overheads. Increased interrupts at the receiver. So at the receiver, what happens is the receiver has to receive all these small chunks of data. So we never guarantee that whatever data that has been transmitted will reach to the receiver. So that means in that particular process what happens? So data received at the receiver is always the receiver is always going to get continuous interrupts about the data. That means receiver may be busy in doing some other task, but what happens is, because of this small data always going to interrupt the receiver for its data reception part. So the next is, it takes more processing time to complete the overall data transfer. Okay. The next one is connection control. So what are the various connection control operations? Simply connection establishment, then data transfer, then connection termination. So these three are the important points. These three are the important points which we normally going to have. So these are the basics which we are going to have under this. Then one more layer is going to be called as a TCP/IP layer. TCP/IP protocol architecture. So TCP/IP is also the technology which we use on the networking. So in this technology, this is normally developed by the US Defense Advanced Research Project Agency for its packet switching network used by the global internet. See, this TCP/IP is a practical application to implement global internet applications. So it is going to use 5 layers only. That means here it is something like a customized OSI model. So always the practical internetwork protocol is always going to be a customized protocol. So this is nothing but a TCP/IP protocol, which is nothing but a practical layered network architecture model. Okay, that means using this type of a network architecture we normally going to transmit. Now your network layer is normally going to function at these 2 levels, network access layer and a physical layer as far as TCP/IP is concerned, and as far as the OSI model is concerned, it is going to work under 3 layers. That means physical layer, data link layer and network layer. So that means these 3 layers, that means here in the case of TCP/IP 2 layers are normally going to get accessed. Coming to the OSI model, let us go back to the OSI model. So I think you can just figure out about OSI model. Okay. Yeah. So in the case of this OSI model, the network layer is normally going to be implemented. The intermediate nodes are going to implement these 3 layers continuously. That is known as physical layer, data link layer, network layer. So in the case of OSI model, the network layer has to compulsorily program for these 3 layers, so that the intermediate nodes are going to upgrade the information at these 3 layers. That means the intermediate nodes are not going to be uniform throughout the life of the network. So therefore we have to compulsorily undergo these changes. Okay. So that means keeping in view of all these various networking devices that we have, keeping in view of all these various types of communication modes, keeping in view of all these protocols and its characteristics, we have to compulsorily communicate the signal from one computer to the other computer by the process known as routing. So due to the what is routing? Routing is normally used to provide a communication path between source computer and the destination computer. So in the next session what we do is we will try to go with routing. Okay, so we will try to complete routing in the next session. Thank you very much for the today's session.